Starting. All attendees are in listen-only mode.
Good morning, good afternoon, good evening, wherever you may be. Welcome to StarWind Software Technical Webinar Series. My name is Max Kolomeitsev. I'll be your host for today. And later on during the webinar, you will also hear from Motti Beck, Director of Marketing at Mellanox. And just to let you know, our today's session is being recorded and you'll be able to view it later on YouTube once we finish the event and upload the recording. Thank you. So, getting 100 gigabit Ethernet performance at the 10 gigabit price. So our quick steps for achieving this goal, at least virtually here on the slides, not showing what we do in the lab, is the following. First thing we need to do is dropping the traditional SAN. This is something we'll discuss on the first slide. After that, we'll see how we transition to a hyper-converged infrastructure and what benefits it brings us. Then we'll see on top of that what's it like to make the most of the hardware you have and to actually maximize the use of it. These are all the steps which bring us closer to getting to the desired goal. And after that, we'll see how we can leverage our capabilities further with Mellanox. And finally, a trick to actually get 100 gigabit performance. And later on, you'll hear from Motti. He'll do an overview on Mellanox technologies and give you some sneak peeks into the new exciting stuff they're doing at Mellanox. And in the end, we'll of course have a Q&A session and we'll gladly answer all your questions. But let's actually set the starting point for our today's event. The thing is that 100 gigabit Ethernet may be expensive, but it may be expensive from the total infrastructure standpoint. As soon as you go down to cards, if you take a 10 gigabit card and let's say you take a 56 gigabit card or 40 gigabit Ethernet card, the price of the cards themselves is comparably low. And if we take 40 gigabit card from Mellanox, being let's say ConnectX-3, it is as expensive as any other 10 gigabit card. So we start at the point where 10 gigabit cards from major manufacturers and 40 gigabit cards from Mellanox cost the same amount of money. So that would be our first jump to get 40 gigabit performance at the price of 10 gigabit. And then we're moving further. So what is the first step we need to do to make it possible to use and leverage 100 gigabit Ethernet performance for the price of 10? First thing is to get rid of the traditional SAN, because it won't be possible for us to achieve our goal with that, at least for now. So no fast interconnects available for commodity SANs today. That means our performance is limited and we cannot really leverage fast interconnects. Then, even if there were special SANs which would do, let's say, 40 gigabit or 100 gigabit, that would be extremely high price to implement because you need completely new infrastructure, new network cards, new HBAs, new switches, and of course the 100 gigabit SAN itself. For now, Google corrects me and says you want 100 gigabyte storage. You cannot do 100 gigabit storage. Well, I hope that changes in the next years. And of course, a dedicated SAN doesn't fit into 100 gigabit Ethernet at price of 10 gigabit Ethernet concept, unless we maybe wait 10 years and a 100 gigabit card will cost as much as 10 gigabit costs today. No, we want to build everything here and now. We don't want to wait. So next step after we drop the traditional SAN is to get down to the hyper-converged infrastructure. With this infrastructure, we effectively drop the major part of the interconnects in the system, and we narrow everything down to just our host and our switching. So we only need network cards and switches at this point. This already gives us better performance because running hyper-converged allows us to leverage local storage and local RAM. So our RAM, which is often used as cache, is not sitting behind an Ethernet link now. It's local. It's within the same PCB board as your hard disks, as your CPU, and effectively your application only needs to write to the local RAM to cache the I/O and then to get it to the local disks. The networking will do its job to synchronize everything and make sure that the hyper-converged architecture itself rebalances everything and keeps your writes coherent and keeps your system fault tolerant. But here's the thing with typical hyper-converged deployments. Even though it doesn't use any proprietary hardware, it's really easy to manage. It effectively requires 3 nodes at least, and 3 nodes also require backend switching, which effectively killed the idea of getting 100 gigabit Ethernet performance at the price of 10 gigabit. We already involved switches in the configuration, so there is no fair way of getting 100 gig at the price of 10 here. It's a nice try, but unfortunately it didn't work this way. So what we'll do next is jump from a hyper-converged architecture to an alternative. So it's also hyper-converged, but it involves a different approach to getting more juice from your servers. Now, in this particular diagram, we see an implementation of hyper-converged architecture by StarWind Virtual SAN. With StarWind Virtual SAN, we require as little as 2 hosts to build our hyper-converged architecture and to get a highly available and redundant platform for your applications and virtual machines with any hypervisor. And as you can see on the diagram, we use one traditional network card, so take any brand you want, and then we use one Mellanox ConnectX-3 card for the synchronization of your I/O between the servers. So StarWind needs these Mellanox cards to get the high performance between your servers. And in this configuration, we have lowered the implementation price. We already don't use any switches at all. We just have a straight connection between the servers, but the interconnect only works for us at 80 gigabit. It's 2 40 gigabit Ethernet ports. So we need to find a trick to get 20 gigabit more from this configuration. And the trick is really easy. So some time ago, me and Marty had a phone conversation and he said, technically we can boost these cards, so they can only provide 40 gigabit Ethernet, but if you do some modifications, and this is something now fully supported by Mellanox, you can push a tiny switch and switch from 40 gigabit Ethernet to 56 gigabit Ethernet. And this effectively allows us to turn our 80 into an effective 100 gigabit Ethernet. So this is how we hit that goal. So right now, we see this configuration. You see your applications running here, and with just 2 servers, any industry standard servers which support additional PCI cards, we can easily get the applications to leverage local storage. Of course, we'll need fast storage for that. And Mellanox hardware to come up to 100 gigabit performance. And if we technically convert that into IOPS, that's going to be something like 4 million IOPS. So right now, the next question would be, where do I usually get 4 million IOPS? That's not a trivial question for today, and we'll definitely return to it during our Q&A session. And right now, I would like to hand over the presentation to Motti, and he'll tell you more a bit about how Mellanox allows their customers to fight the data growth and what the new things available from Mellanox. So Motti, are you with us?
Thank you, Max.
You're
Thank you,
welcome.
Max, and hello, everybody. Again, as Max said before, my name is Motti Beck. I'm part of the marketing team here at Mellanox, and I'm more focusing on the enterprise data center. So I have a couple of slides to discuss our technology and how we jointly enable higher storage performance. And actually, the first slide that I would like to do is actually to, the next slide is to show a couple of market trends that basically all of us are aware of. That is not going to be any surprise, but all of them actually are driving the need for higher performance, data center performance, especially on the storage itself. So I'll move to the next slide, and I have some technical issues here, so maybe Max, you can move it to the next slide that talks about the different market trends. And it's not going to be a surprise to any one of us that today there are more and more mobile devices that are being used, which mean basically, and all of us are aware that the mobile devices they have a very to none compute power. They are more like a nice GUI interface to the data center where the real job is being done. So, but more people are moving, especially the professional task forces that are moving to mobile. More job needs to be done at the data center, specifically with more applications that the applications were there before, but instead of running on your desktop or laptop, now they need to run on the data center, and all the apps that are on the mobile now, you can do much faster job. And actually, there are, more data resources and more data to analyze, and everything needs to be done in almost real time because we are mobile, and everything needs to be manipulated or processed in a very fast way. So this is the market trend that no surprise here, but everything again requires higher performance. And the key is here, of course, not just higher performance, but higher performance at lower cost. And as Mark said, let's see how we get a performance of 1 gigabit per second and the cost of 10. And this is the webinar is all about. So moving to the next slides, just a couple of things about Mellanox. And about Mellanox itself, just in short, for the guys that don't know us, Mellanox is a company that only focuses on providing interconnect solution, end-to-end interconnect solutions for the data center. We have all of our IPs ourselves, including the controllers, including the NICs and the subsystem that we are doing. Everything is in-house, so in a sense we are one stop shop for anything that you need for connecting your data center PCI Express to PCI Express. And recently, actually up to couple of months ago, we were the leader on the 10 and 40 GbE. And as Max said, also there is an option to run it on 56 gig per second. But a couple of months ago, we announced our end-to-end solutions that is going to be up to 100. The 100 solution includes our Spectrum switch that can support all the speeds, including 10, 25, 40, 50, and 100, unblocked 6.4 terabit per second throughput, unblocked performance. Our recent NIC, which is the ConnectX-3 that can support the same speeds, and to complement it, we have also our network, the cables, because to run 100 gig per second speed, it's not trivial. Some of the cables are copper, passive, up to 5 or so meters, but we can support, of course, with optical cables, 100, 300, and with our gateways, we can support even tens of kilometers, depends on your need. So in a sense, we have a full control of not just the full end-to-end solution, but we can guarantee end-to-end higher quality connection between the different servers. And it's pretty important today because the data centers, as all of us are aware, are building today out of commodity servers, and the connectivity between the servers are pretty important. If the communication is going to be slow, then the overall data center is going to work slower. So the networking is an important element for the performance and the overall efficiency, I would say, of the enterprise or the cloud data centers. So moving to the next slide, and Max, if you can move it, because for some reason I'm remote and I cannot, for some reason, control it. But when we are talking about for example, on the NIC itself, just to talk about the speed itself is half of the picture. The speed itself, everybody can tell, you know what, we are supporting 10 GbE, 40 GbE, or 100 GbE. The key is how efficient is the implementation on the controller itself. And the Mellanox is unique and pretty much leads the market with what we call the offload engine, that everything stateless offload tasks can be done in the silicon itself instead of using the CPU and the operating system to run the jobs. So once you have a more efficient implementation of the protocols, means you can use hardware offload, then the overall latency and the overall performance is higher. It's not just the overall performance is higher, but you are leaving more cycles for the CPU to run the real job instead of spending cycles on running the communication task that has nothing to do with running the job itself. And today, the Haswell, for example, CPUs are so expensive, and they are more than 2,000 a piece, and you don't want to use cycles for things that are not, or you are trying not to use cycles for things that are not, doesn't have to do with the job itself. So this is just, an example of a benchmark that we did comparing us, in this case I took the 10 GbE, comparing us to another, one of our competitors, and you'll see that the overall performance on the throughput, on the latency, and the setup communication is much better in a significant percentage, and although again the cost is the same or lower. Even more, another example, moving to the next slide, another example that can give you even a better idea why the offload engines are so much more important is like the NVGRE. This is for the overlay network technologies that are available today. And there are two ways to do the overlay, this particular case, since it's more on the Microsoft, I'm talking about the NVGRE, but it's the same about the VX or Geneva in the future. You can do it in software, or you can do it in using the hardware offload, and this is one of our NICs, the ConnectX-3 Pro on the 10 GbE, and then actually the better that you can see that about 50%, you are getting 50% higher bandwidth if you are using the offload engine to do the overlay network or to implement the NVGRE. It's a stateless offload engine. It's pretty well defined, and there is no issue to implement it in the hardware, in the silicon itself. And this is just another great example on, and there are many of them, but we don't have enough time, so I just brought a couple of examples, the previous one and this one, and there are more. So moving to the next slide, let's see, we'll wait for, so this is like just to show not just on the low-level benchmarking, but also on the application. This is the CPS, which is an appliance that the Cloud Performance System appliance that and this is the implementation that Dell does, and published at the conference Ignite a couple of months ago of the NVGRE offload compared in real life. You can see that in average it's about 3x performance boost. This is again a good example at lower cost using our end-to-end interconnect solution. Moving to the next one. So to make, and this is pretty much my last slide, and then we'll go to the Q&A. So to make, if you want, you know, to build it yourself or to test the performance, what Mellanox did, we came with our Cloudx initiative, which is a turnkey cloud architecture. We developed a couple of reference and certified, let's call tested reference architecture, including over Microsoft, and it's available on our website, and basically you can build it, it's proven, or of course to work with our partners like StarWind to check the performance. So again, moving to the last slide that I have, again, we have today our overall solution starting from 10. Today we are at 100 gig per second. Hopefully soon we are going even to double it to the 200. We have all the technologies, the IP, and the knowledge in-house, and we can guarantee, I believe, the best performance and best quality of service and the reliability connection in the data center itself. So this is basically concludes my presentation, and we can actually move to the Q&A.
Okay, Moti, thank you for the excellent presentation, and I'll pull up the questions and answers panel here and start working on the questions. So first question we have today is, does ConnectX-4 100 gig Ethernet require a new PCIe version which is not out yet, or can the existing motherboard handle 100 gigs?
So the ConnectX-4 100 uses the existing PCI Express Gen 3. The only thing that is required is 16x instead of the 8x that you need for the 50 up to 56. On the PCI Express, there are 8 lanes. Each one of them is about 8 gigabit per second. So the maximum on the 8 is about 64 or a little bit in 64. And this is why you need a 16x to support the 100.
Okay. One more question. How many hyper-converged nodes are supported? So I think this one goes to me. With StarWind, the hyper-converged cluster can grow up to 64 nodes. That's the limitation for Hyper-V deployments. And depending on the hypervisor, StarWind can grow as big as the actual hypervisor cluster. The next question is, yeah, I think it's about Mellanox. The NIC MCX 416A with ESXi versus 6 RIHV OVS Zen 65, and I'm not sure this is something we can handle within the webinar. So I guess I'll dedicate this question and answer it via email, because that may be too difficult here.
If it's too technical, it's not. If it's too technical about okay, let's go and about the specific driver and so on, sure, you can send me the email. It's Motti, M-O-T-T-I @mellanox.com, and I'll verify. Or Max, you can forward me the email.
I will do, definitely. Okay, and one more question. Can the StarWind work on 1 gig connection? Yes, StarWind can also work on 1 gigabit connection, and this is the, I think, 20 or 25% of our deployments are SMBs who deployed the virtualization environment with just 2 servers and 1 gigabit backbone between them. And this allows you to get up to 20 to 25,000 IOPS for your application. Yeah, so this is a pretty much widespread configuration. Then a question here, is the presentation available for download? Yeah, we'll have a recorded version available on YouTube later on. And one more question is, what is the difference between StarWind Virtual SAN and VMware vSAN? So the first difference would be that StarWind Virtual SAN is in iSCSI SAN, and VMware vSAN is technically object storage. So it won't be an apples-to-apples comparison from the beginning. If we talk about the problem we're solving with our solutions, StarWind requires just 2 nodes to build a highly available cluster, whereas VMware requires 3 servers at least to get a highly available virtualization environment. Another solution thing would be that StarWind doesn't require SSDs mandatory in each server, and VMware does require the SSD. So they have a little less flexibility from the hardware standpoint. So you need to use the nodes which are pre-certified for vSAN, or go with EvoRail solution. With StarWind, the hardware choice is broader. And another thing is that with VMware vSAN, you're licensing the entire cluster. So if you have, let's say, 8 nodes, you need to buy vSAN licenses for the entire cluster. And even if you don't need that, and if you would technically be able to feed storage to the entire 8 nodes from, let's say, a small 2-node cluster, or from 2 nodes within the same cluster, you still need VMware vSAN license for all 8 hosts. With StarWind, you only license the nodes you use for storage. So let's say if you have an 8-node cluster, but you're okay with feeding storage from 2 nodes only, you only license 2 nodes. Okay, I would also make an announcement here that StarWind does not disclose pricing just depending on the connection speed between the servers. So I'll get back to you via email with all the pricing answers after the webinar. There was one more question for Motti. Let me see. Are the switches and NICs available on USA market at now?
Yeah. Okay, so the question is what switches. The cards, first of all, up to 56, all of our switches are available, whether on the US, and I would say not just the US, it's available worldwide. And on the 100, the NICs and the cables are available, and the switch itself is going to be available for, it's going to be available later this year for the general public.
Okay.
But again, Mellanox is not just a US, we have worldwide offices, so we are pretty much selling to, I would say, virtually all the countries in the world.
Okay, thank you. And there's one more question for you, Marty. Do you see a demand for links faster than 100 gigabit between the servers?
Actually, this is an excellent question, and the answer is yes. And I'll give a little bit lengthy, maybe too much, but at the end of the day, it's a matter of higher efficiency. And again, we see that sometimes in order to solve a performance issues, the IT managers continue to add servers instead of identifying the real issue, and in many cases is actually solving the bottlenecks that are associated with access to the storage. And recently, we see more and more demand and deployments of our 40 GbE and not just the 40 GbE, also on the 56. So there is a mode in our switches that internally it can run on 40 GbE, which is 56 GbE, which is not an industry standard, but then connecting to the data center itself or the client over 10 or over 40. One great example, by the way, about the need of 40, if you'll take a look on Azure, they are using the 40 GbE, which is the largest, I would say, among the largest cloud deployments in the world today. And the efficiency today, the power of the CPUs is so high, there are so many cores that it can support more than just of course, the 10 GbE. For example, I encourage you guys to take a look on the demo that we did, the joint demos that we did at Ignite. It was last, I believe, May, with Microsoft. In these demos, they were using a Windows Server 2016, but a year ago they used the 12. But on the 16 itself, we showed a demo of 100 gig per second using the ConnectX-4. And it shows very high efficiency. So I believe that it's not just the market is moving now to the 100, but once all the pieces are going to be in place on the 100, probably we'll see even moving faster to the 100 than they moved from the 10 to the 40. Oh. So again, higher efficiency, the CPUs have a higher bandwidth, the SSDs are there. There are new, I would say, architectures, storage architecture like the solutions that StarWind came and brought to the virtualized data center. So the movement is pretty fast and deployed today.
Okay, one more question here, and I think that's the last question we have in line here. Which model cards did you use in your solution to get 100 gig Ethernet? So I guess this question goes to me, but Marty, do you remember? I think it was ConnectX-3 which you sent us to do this experiment. Yeah, so we used ConnectX-3 for that, and we did.
Yeah, if I may, I send you the ConnectX-3 because at the time this was available. So it was ConnectX-3, and there are two on the ConnectX-3. We have two cards, the ConnectX-3 and the ConnectX-3 Pro. And the only difference between the two of them is that the Pro includes the offload engine for the NVGRE for the overlay networks, but otherwise they are the same. If you are not using the NVGRE and you don't need it, the ConnectX-3 is going to be more than enough. And also the cards themselves, not just the switches, they automatically can switch to the 56. So all the cards that we have can work as the 10 GbE, 40 GbE, or the 56. And you use the ConnectX-3 on the 40 gig or 56 as well.
Okay, thank you for that. Okay, I would like to thank everyone for attending our today's event. I hope it was interesting for you. And as I told, after the webinar, we'll send you a link to YouTube where you'll be able to view the recorded version or share it with your friends or colleagues. And once again, thank you and have a great day. Bye-bye.